Yeah, so as I said to the machine today, I would like to take some time to explore the core Dionysus 3 loop. And he thought for a little bit. I can't see that one. So the core loop in Dionysus is the OODA cycle. So heartbeat agent, top level planning interval, consciousness manager. And we're going to dive into these in a bit. So that's why I'm just giving you a surface view. Perception agent observes, obviously. Reasoning agent orients. And then the metacognition agent makes some decisions. And then as a result of all that, you act. So canonical, yeah, canonical implementation of the ODA cycle is here with the heartbeat agent right there. So a good exploration in order is we're going to read the loop entry point, which is the heartbeat agent. It calls the consciousness manager. Traces one tick. We're going to trace through one tick and see how the observe, orient, decide, and act loop happens, including how we use the graffiti service to we use a gateway to record. Benefit of the graffiti service is, well, it's been a while since what, a year plus. So graffiti service connects to Neo4j, and Neo4j is the graph database, allowing for multi-hop. It's a relational reasoning. Um, oh, I mean, most people know Neo4j, so I won't over-explain it. All right, and finally, we have a metacognitive overlay. The goal of the metacognitive overlay is you'll see that I have a three-layer architecture, which I borrowed, air quotes, from, there's a paper called, is it meta-awareness? Well, the key things about this paper is that it introduced me to several concepts, which I'll discuss soon. Trust me, they come up all the time. The concept of meta awareness, first of all. Second was the concept of opacity and transparency, and that's the phenomenological opacity and transparency. And then the third thing was, did I say mental action? Mental action, which led me to attentional affordances, but we'll talk about that later. All right, each of these we're going to explore in more detail as we walk through the code. And it's going to be a long walk, but I definitely wanted to make sure I had everything laid out instead of just dumping a bunch of code out here. Um, all right, so precision, agency, and epistemic gain, particles, and the work of surprise. This is based on active inference, which is predictive brain. Uh, what else is another way to say? It's a lot of Carl Friston's work. So what you'll see is basically it's a loop, as you can see by the observe, orient, decide, act. Uh, it's a loop. I mean, I won't over explain yet. Um, so we'll just jump in. Where do you want to start? Code level trace, read the actual loop and walk it. The conceptual architecture, let's do that first. Or a specific subsystem, memory writes during act. Um, act is one of the, there's act, there's SOAR, um, it's not a consciousness framework, it's just a thought framework. You'll see. So memory writes during act are subsystems. I'm not going to jump into them. S2 arbitration and thought seed competition. Thought seed competition is the most interesting to me, as you'll see. It's basically the path from one thought particle, one agentic thought particle, all the way through to consciousness, through the inner screen. So put in those in order of conceptual dependence, clarity, dependency. Just I kind of wanted to say just whatever it takes for me to understand it. So let me go in auto mode. Yeah, that's what I said. So, and I'm actually gonna what you call it, dive into these kind of patiently. So this will be long, drawn out. Um, I probably won't come back and edit it because it's a lot. You'll see. But ultimately, I'm going to take my time with it to like dig all into the nooks and crannies, so that ultimately any element of this that I extract and release will have been explained in the concept of the larger entity and why I built it that way, what the weird quirks are, any weird remaining holes or opportunities for extension or expansion. I'm going to let it cook. All right. It looks like it's coming up with something useful for us. It's funny because I haven't looked these papers in so long. Conceptual layer. You know what? I am going to have this read to us because might as well. I might have a V3 enhanced because why not? Put these on my headphones so I don't annoy the crap out of my wife. All right, let's see. Okay, this is gonna go bad shit.
Core loop, conceptual frame plus code trace. Conceptual layer, specs. 2 papers fuse into the architecture. Sandved, Smith, and DaCosta, spec 040, gives the vertical axis. Particles arranged in a Markov blanket hierarchy with mental actions modulating precision below. Agency equals mutual information between internal and active paths. Seragnoli, spec 040, adds epistemic gain, uncertainty reduction events that feel like aha moments. Spec 043 adds the horizontal axis, episodic meta-learning, where each completed cycle becomes a cognitive episode and surprise, prediction error, becomes the training signal that biases future strategy. Mechanical layer, code trace. The actual loop lives in 3 layers, each thinner than the one above it. Orchestration, API/agent/heartbeat_agent.py:914_run_decide. This is the single entry point of one tick. It assembles a dict context into an OODA context, fires hooks, runs hexes consent plus boundary checks, and dispatches the OODA phases. Cognition primitives. API/cognition/OODA_cycle.py. 3 thin classes. System 1, agent.observe, fast pass, runs a small agent's tool calling agent with a 15-second timeout. Metacognitive arbitrator.arbitrate, calls managed metacognition agent.arbitrate_decision to return use_s2 reason confidence. Archon's force_s2 short circuits this. System 2 agent.decide_and_act, slow pass via decide_s2 provider gateway, Claude agent SDK, or small agents per decision_provider, 60 seconds timeout, catches cognitive cycle interrupt. Cross-cutting in the orchestrator. Between phases, run decide records MIDCA phases, perceive, to interpret, to eval, to intend, to plan, to act. Runs anomaly detector pipeline. Retrieves Atlas lessons plus reflection recall to prefix the S2 prompt. Computes composite entropy for thinking token governance, and fires PRE_OODA/PRE_action/POST_action hooks. The single tick end-to-end. Pre_OODA hook arrow, hexes consent arrow, boundaries fetch down S1. Observe 15 seconds. Midka, perceive down boundary check on S1 output down arbitrate, S1 versus S2. Midka, interpret, eval, down arrow, use underscore S2 equals false, right arrow. Midka,
That's systems, right?
intend slash plan slash act, S1 underscore accepted, finalize, return down arrow, use underscore S2 equals true, down arrow. Anomaly detector pipeline, replay loop, A distance, DR free, down arrow. Goal plan manager dot commit underscore 4 underscore S2, down arrow. PRE underscore action hook
Reaction.
plus
Okay.
Atlas lessons plus reflection recall plus EFE goals, down arrow. Composite
That's
entropy prefilter
free
to
energy.
hierarchical underscore EFE open bracket quote composite quote close bracket down arrow. S2 colon decide underscore and underscore act via decide underscore S2 gateway open parentheses 60 seconds close parentheses dash 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 MIDCA colon
That's
plan,
Midka.
comma,
Yeah.
act, down arrow, boundary check on S2 output arrow. Plan deviation tracker arrow, post underscore action hook arrow, midka, finalize arrow, run underscore post underscore cycle underscore background. Optimizer, reflection, safety watchdog, token recording. Where the conceptual maps to the mechanical. Particles, spec 040, arrow, S1 agent equals cognitive particle. Arbitrator plus Atlas lessons equals passive metacognitive, monitor. Managed metacognition agent dot arbitrate underscore decision plus composite entropy precision modulation equals active metacognitive. Mental actions arrow, composite entropy injection into hierarchical underscore EFE
EFE.
controls. Claude SDK extended thinking tokens. That's literally a precision modulation of the lower level S2 process. Epistemic gain slash
Epistemic gain.
surprise,
That's surprise.
spec 043, arrow, not in the live OODA underscore cycle dot py data path. Lives in underscore storage dot get underscore lessons underscore by underscore context atlas and the post-cycle background tasks. Spec 043's post-OODA calculate surprise to record episode is the horizontal axis that wraps this loop. Cognitive core limit FR-015 to enforced implicitly by the two-level S1/S2 SOFAI split plus the arbitrator. No recursive metacog beyond managed metacognition agent. Subsystem branches worth a deep dive in order of payoff. Decide underscore S2 provider gateway. API/agents/providers/factory.py. This is where the S2 arm forks between Claude Agent SDK and Smol agents. Understanding it explains how the same loop runs against two very different reasoning substrates. Managed metacognition agent dot arbitrate underscore decision. The actual S1/S2 gate. Its inputs, energy underscore ratio, complexity, historical underscore success, are the live precision/agency dials. MIDCA phase registry
Okay.
plus cycle memory bridge. How each tick becomes a persisted episode, which is the substrate spec 043 builds on. Anomaly detector pipeline plus run underscore post underscore cycle underscore background. Surprise detection and the reflection/optimizer loop. This is where the learning in the loop lives. Composite entropy/active inference service dot calculate underscore composite underscore entropy. Metabolic load to thinking budget. The clearest example of mental action precision modulation in the running system. Want me to go into one of those next? My suggestion, decide underscore S2 plus managed metacognition agent dot arbitrate underscore decision as a pair. That's the actual decision physics of the loop, and everything else is scaffolding around it.
Okay, now I need you to explain to me, like I was a fifth grader, what you just told me. You can use the names of the key things, but I just want more of a guided tour of what's happening and possibly more clickable code along the way. My willow voice has been tripping this week. I don't need team collaboration. No. See, I got irritated at it. I was throwing the F ball. It was 3 a.m, y'all, or whatever. Okay. If you can go back through what you just told me, but as if I was a fifth grader, and include more clickable links to the code, as well as every once in a while, ground me in the bigger picture. I want you to do a Richard Feynman style explanation. Let me know you know what a Richard Feynman style explanation is. And you don't necessarily have to tell me all the things in here, but I do want the key concepts covered, and then we could do a question and answer so I can get some clarity up until this part. Unless you suggest I go a little bit further and then come back for the loop back. So let me know what would be the best way to teach me what's going on here at the level of conception that would help me continue. Okay, I'll try not to sub-vocalize y'all. I'm gonna close some of this stuff. All right, big picture, yes, please. Okay, good. Some Feynman style. Let's find some more interesting voices.
¿Qué impacto tuvieron en las vidas de estos testimonios?
Carmela agreed, with a nod of her head toward the young girl.
You know, back in the day, I used to be an adventurer too. Then I got married and settled down.
Hey, I'm Valentin, 18 years young and a student. Feel free to use my voice for your projects. I'm very excited to see what's coming.
Launching the next big startup, breaking down market trends, or building a brand that stands out. This is the sound that people...
ओह अच्छा, तो आप यही पता करना चाह रहे थे? चलिए, मैं इसे सिंपल तरीके से समझा देती हूँ ताकि कोई कंफ्यूजन ना रहे.
Hallo, mein liebes Kind. Ich bin der Weihnachtsmann. Ja, der echt.
Desde ese día, nunca olvidó que...
Hey, I'm Heather. I love exploring. Are you ready for an adventure? Let's do it.
Listen up, crew. Danger will be...
Кузя подпрыгнул, чтобы посмотреть, куда это он. Кувыркнулся и...
In a world filled with wonder and ruin.
That's what we're
The
doing,
last
sure.
light doesn't fall quietly. It rises in the throat of the storm and dares the universe to answer.
Okay, it breaks off early, but we'll figure that out.
Yes, I know what a Feynman-style explanation is. Richard Feynman taught physics by refusing to hide behind jargon. You pick a concept, explain it like you're talking to a curious 12-year-old. Find the spot where your explanation gets fuzzy, and that's the spot you don't actually understand yet. If you can't say it plainly, you don't know it. Analogies come first, math second. So that's what I'll do.
They say the stars shine brighter when a wish is true, and that night, one wish changed everything.
That's frustrating, y'all. I had it.
The heart has eyes which the brain knows nothing of.
Nah. Let's go cinematic, I guess. No. I probably will not have time to come back and clean this out like I would like. What's it, announcer? Man, I swear I chose that one.
Through forests.
Ach, witaj, kochany sąsiedzie, w ten cudowny poranek. Słońce złocistymi promieniami liże źdźbła trawy.
That's the one. It'll get annoying like sooner than later, trust. There we go. Obviously.
Ach, witaj, kochany sąsiedzie, w ten cudowny poranek. Słońce...
I don't know what just happened. Wow, really?
Yes, I know what a Feynman-style explanation is. Richard Feynman taught physics by refusing to hide behind jargon. You pick a concept, explain it like you're talking to a curious 12-year-old. Find the spot where your explanation gets fuzzy, and that's the spot you don't actually understand yet. If you can't say it plainly, you don't know it. Analogies come first, math second. So that's what I'll do. Also noting, no M dashes, your rule. And you opened API/agents/providers/factory.py, which is one of the branches I flagged. We'll get there. The big picture first. Imagine Dionysus is a little creature that lives on a server. Every few seconds it wakes up, looks around, and asks itself one question. What should I do right now? That's the whole loop. Everything else is just how it answers that question, carefully. One wake up and decide is called a heartbeat. The pattern it follows to decide is called OODA, observe, orient, decide, act. Pilots invented it for dogfights. Dionysus uses it for thinking. The two brains. The creature has two ways of thinking, just like you do. Fast brain is your gut. You see a ball flying at your face. You flinch. No thinking. Cheap, quick, usually right. Slow brain is when you sit down with paper and figure something out carefully. Expensive, slow, but it can handle hard problems. In the code, these have names. Fast brain equals system 1, agent.observe, gives itself 15 seconds. Slow brain equals system 2, agent.decide underscore and underscore act, gives itself 60 seconds. Big picture check-in. Almost every smart AI system that thinks well has some version of this fast/slow split. Daniel Kahneman wrote a whole book about it. The acronym in the code, SOFAI, stands for Slow and Fast AI. Dionysus is built on this idea. The referee in the middle. If you only had a fast brain, you'd be impulsive. If you only had a slow brain, you'd freeze every time a fly landed on you. So you need a referee who decides. Is this situation simple? Trust the gut.
Yo,
Is it tricky?
I can't do that.
Wake up the slow brain. That referee is the metacognitive arbitrator. The fancy word metacognition just means thinking about thinking. The referee doesn't do the thinking. It just decides who should. It looks at three things to decide. Heartbeat underscore agent dot py colon 179 to 189. How much energy do I have left? Like you at 11 p.m. versus 9 a.m. How complicated is what I'm being asked? Have I usually been right about stuff like this before? Then it returns a tiny verdict. Use underscore S2. True or false. Reason, confidence, 0.85. One full heartbeat, told as a story. Here's what happens when Dionysus wakes up. The whole story
Okay, we gotta do that again. 'Cause I'm a little
Yes, I know what a Feynman-style explanation is. Richard Feynman taught physics by refusing to hide behind jargon. You pick a concept, explain it like you're talking to a curious 12-year-old. Find the spot where your explanation gets fuzzy, and that's the spot you don't actually understand yet. If you can't say it plainly, you don't know it. Analogies come first, math second, so that's what I'll do. Also noting, no M dashes, your rule. And you opened API/agents/providers/factory.py, which is one of the branches I flagged. We'll get there. The big picture first. Imagine Dionysus is a little creature that lives on a server. Every few seconds, it wakes up, looks around, and asks itself one question. What should I do right now? That's the whole loop. Everything else is just how it answers that question carefully. One wake up and decide is called a heartbeat. The pattern it follows to decide is called OODA, observe, orient, decide, act. Pilots invented it for dogfights. Dionysus uses it for thinking. The two brains. The creature has two ways of thinking, just like you do. Fast brain is your gut. You see a ball flying at your face, you flinch. No thinking. Cheap, quick, usually right. Slow brain is when you sit down with paper and figure something out carefully. Expensive, slow, but it can handle hard problems. In the code, these have names. Fast brain equals system 1, agent.observe, gives itself 15 seconds. Slow brain equals system 2, agent.decide underscore and underscore act, gives itself 60 seconds. Big picture check-in. Almost every smart AI system that thinks well has some version of this fast/slow split. Daniel Kahneman wrote a whole book about it. The acronym in the code, SOFAI, stands for Slow and Fast AI. Dionysus is built on this idea. The referee in the middle. If you only had a fast brain, you'd be impulsive. If you only had a slow brain, you'd freeze every time a fly landed on you. So you need a referee who decides, is this situation simple? Trust the gut. Is it tricky? Wake up the slow brain. That referee is the metacognitive arbitrator. The fancy word metacognition just means thinking about thinking. The referee doesn't do the thinking. It just decides who should. It looks at three things to decide. Heartbeat_agent.py:179 to 189. How much energy do I have left? Like you at 11 p.m. versus 9 a.m. How complicated is what I'm being asked? Have I usually been right about stuff like this before? Then it returns a tiny verdict. Use_S2. True or false? Reason. Confidence. 0.85. One full heartbeat, told as a story. Here's what happens when Dionysus wakes up. The whole story lives in one function. Run, decide. 1. Safety check first. Pre-OODA checks. Line 783. Before anything, the creature checks. Am I allowed to be doing this? It asks something called hexes, which is basically the rules of the house. Things like don't lie or don't write to the database directly. If hexes says no, the heartbeat stops right there. Big picture check-in. This is important. The creature can't bypass its own ethics. Every tick begins with consent. That's a deliberate design choice, not a coincidence. 2. Fast brain takes a look. Line 963. S1 reads the situation and says something quick like, I notice the user is asking about X. Obvious next step, Y. 15 seconds, max. 3. Referee decides. Line 987. Was that good enough? Or do we need to think harder? The referee returns its verdict. 4. A. If the verdict is good enough, line 1030, the creature accepts S1's answer and goes back to sleep. No expensive thinking needed. Most heartbeats end here. 4. B. If the verdict is, this is tricky, wake up slow brain. Now things get interesting. The creature does a bunch of preparation, looks up lessons from past similar situations, line 1063, called Atlas lessons, like checking your notes before a test. Looks up reflections from previous heartbeats, line 1084. Last time I tried this, here's what happened. Calculates how mentally tired it is, line 1127, composite entropy. If it's tired, it gives slow brain less time to think. If it's fresh, it gives it more. Then runs slow brain, line 1140. 5. Slow brain comes back with a plan and an action. 6. Safety check the answer too, line 1153. Did slow brain say something it shouldn't? If yes, throw it out. 7. Record what happened, fire follow-up tasks, go back to sleep. Line 1196. That's one heartbeat, then it does it again. Forever. The two big ideas behind it all. Idea 1. 2 brains plus a referee. That's the loop. Everything else is decoration. Idea 2. The creature watches itself. Every heartbeat gets recorded. When it's surprised by an outcome, I thought X would happen, but Y happened. That surprise becomes a teacher. Next time, it adjusts. This is what Spec 043 is about, and it's the part that makes the creature actually learn instead of just running in circles. Big picture check-in. A loo.
Okay, so I think provider is going to be where we go into memevolve, probably.
A loop that watches itself loop is the whole point. Without that, you just have a chatbot that resets every turn. With it, you have something that gets better at being itself. My recommendation for what to do next, I think we should stop here and do Q&A. Reason. The mental model you need to lock in is fast brain, slow brain, referee, repeat with self-watching. If that's solid, every other part of the system, the provider gateway, the active inference math, the hexis boundaries, the mid-phase recording, the memory bridges, is just details about how one of those four things works. If we push further before that's solid, the new info won't have anywhere to land. Some questions you might want to ask just to seed the conversation. What does the referee actually look like inside? How does it decide? What's the difference between MIDCA and OODA? You mentioned both. Where does memory fit in? When does it write things down? What's hexis really? Like a list of rules in a file. Why is this called consciousness and not just a program that loops? What changes between heartbeats? Does it remember the last one? Pick one or ask your own. Once the four pillars feel solid, I'll suggest we go into API/agents/providers/factory.py, the file you opened, because that's where slow brain forks into either Claude or Smol agents, and that's a clean next step.
Got it. Let's see here. I'm gonna let's start with this one. I need to ask it, make sure all this is written in docs. At each zone too. Okay. All right, I'm going to break this up into two pieces because it will anyway, if not three. I'm going to skip all that. All right, we'll stop here. No. I forgot to press enhance.
Great question. The honest answer is the referee is much simpler than it sounds. And there's a twist I want to be straight with you about. What the referee actually receives. When the fast brain finishes, it hands two small pieces of paper to the referee at OODA_cycle.py:181 to 189, paper number 1, Here's what Fast Brain said Output. Whatever S1 said. Confidence, 0.6. Paper number 2. Here's how I'm doing right now. Energy, 0.4. 40% battery left. Complexity, 0.7. High because there are active goals. Or 0.3.
Okay, I had, excuse me, paused there for a bit. So let me, I like to close some of these. Let me make sure I am, let me make sure I am going back a little bit. Sorry, I somehow or other opened all my damn marketing stuff. Determine the marketing thesis. Are you serious? Sorry, man. Okay, I'm not doing this. I just realized I could. Okay, so what I do need is to get back here, not this. You can tell when it's marketing day, dude. All right. 3.7. Okay, I'll pick up from a little bit before here. There we go.
Or 0.3. Low because nothing's going on. Historical underscore success, 0.85. Hard-coded for now. That's it. 3 numbers and a string. The referee doesn't see the user, the database, the goals, the lessons. Just a tiny dashboard. Big picture. The referee is designed to be cheap. If the referee itself were expensive to run, you'd just have moved the problem one floor up. So it gets a small dashboard and decides quickly. What the referee is supposed to return. A verdict. One small dict, OODA_cycle.py, 166 to 193. Use underscore S2. True or false. Reason. Why I picked that. Confidence, 0.0 to 1.0. The orchestrator then checks one thing only. Heartbeat underscore agent dot py 1030. If not, arbitration dot get, open parenthesis quote, use underscore S2, quote, close parenthesis, hash, take FastBrain's answer and go home. So the referee is just the gate, open or closed. How the verdict is actually made, the matryoshka. Now here's where it gets interesting, because the referee is a stack of dolls inside dolls. Watch.
Yep.
Doll 1. Metacognitive arbitrator. Dot. Arbitrate on the OODA loop. This is just a coordinator. It checks one shortcut first. Line 167. If context.force underscore S2. Return. Use underscore S2. True. Reason. Archon underscore override underscore force underscore S2. That's the emergency button. If something outside the loop, a workflow, a human, the Archon bridge, wants...
And Archon is Cole Medin's harness. It's a workflow harness that makes the system more deterministic.
To force deep thinking, it sets a flag, and the referee skips its judgment entirely. Otherwise, it opens up. Doll 2. Managed metacognition agent. Dot. Arbitrate underscore decision. This is a thin wrapper that holds onto the agent and forwards the call. No logic of its own. Inside that. Doll 3. Metacognition agent. Dot. Arbitrate underscore decision. Also a thin wrapper. It calls underscore delegate. Open parenthesis. Dot. Close parenthesis. Inside that. Doll 4. Underscore delegate. And here's where the truth comes out.
Okay, I think ultimately the provider is where we finally get to our memory. But it gets the memory in a state. So, Feynman moment. Okay, so I'll just see if I can get all the way to the end with this one.
Number 1, try to find a real provider, an external Python package. Provider equals self._ensure_provider, parens. If provider is not none and has ATER, open paren, provider, comma, method, close paren, colon. Return, provider.arbitrate_decision, open paren, proposal, comma, context, #2. If no provider, try a network boundary, RabbitMQ or HTTP. Try, return, await, self._call_boundary, dat method, ... accept, cognition boundary unavailable error, #3. If that fails too, fall back to local stub, return, await, self._delegate_local, open parenthesis, method, comma, ... close parenthesis. So the referee is really 3 possible referees, tried in order. External provider package. A separate Python module the system loads if Dionysus_metacognition_provider is set in the environment. This is where the real smart referee is supposed to live. Network boundary. A service running somewhere else, RabbitMQ or HTTP, that does the deciding. Local fallback. The cheap backup at metacognition_agent.py:373 to 375. The twist, the Feynman moment. Look at the local fallback, the whole thing. If method equals, quote, arbitrate_decision, quote, colon, proposal equals dict, open parenthesis, args, open bracket, 0, close bracket, close parenthesis, if, args and istigris, open parenthesis, args, open bracket, 0, close bracket, comma, dict, close parenthesis, else, return, quote, approved, quote, colon, true, comma, quote, proposal, quote, colon, proposal, comma, quote, reason, quote, colon, quote, local_fallback, quote, 3 lines. It returns approved, colon, true. But the orchestrator looks for use_s2, not approved. So in the local fallback path, arbitration.get, open parenthesis, quote, use_s2, quote, close parenthesis, returns none, which is falsy, which means the referee always says, fast brain is fine, go home. In other words, if you're running Dionysus without an external metacognition provider configured, the referee is hollow. It's not deciding anything. Slow brain only ever fires when the force_s2 emergency button is pressed. Big picture. This is a really common pattern in growing systems. You build the socket, the place where smarts plug in, before you build the plug, the actual smarts. The architecture is ready for a smart referee. The smart referee isn't in this repo. It's expected to come from Dionysus_cognition.metacognition or a separate service. This is why I told you the conceptual layer matters before the code. The code right now is a frame. The picture is partly painted. So how does it actually decide in the real? When a real provider is hooked up, the inputs are those three numbers plus the proposal. Low energy implies lean toward fast brain. You can't afford slow thinking when you're tired. High complexity implies lean toward slow brain. Low historical success implies lean toward slow brain. Your gut has been wrong. Think harder. High S1 confidence in the proposal implies lean toward fast brain. A real provider would weigh those into a use_S2, true/false decision. The shape of the decision is wired in. The math is plugged in elsewhere. Where this fits in the bigger picture. You now understand the loop. Heartbeat to S1 to referee to maybe S2 to record to repeat. The two brains, S1 fast, S2 slow. The referee is a gate, fed by a tiny dashboard, with the actual decision logic pluggable through a provider system. Right now, in this repo, it's mostly an empty socket plus an emergency override. A really useful next thing to look at would be the provider gateway for slow brain itself, since you opened that file. That's API/agents/providers/factory.py and decide_S2. It's the same pattern, pluggable provider, but for the thinking part instead of the referee part. Once you see it twice, the pattern locks in. This whole codebase is built as swappable cognition pieces behind thin local stubs. Want to go there next? Or do you want to ask another clarifying question on the referee first? Good ones to ask. Why design it as a socket if the plug isn't here? Or, what's force_S2 actually used for in practice? Or, how does historical_success get computed if it's hard-coded at 0.85?
I'll probably stay at a high level. Okay, let's keep it a high level and just keep moving forward. What does that look like? And by high level, I don't mean disappear into abstraction. I mean just whatever is the core path we want to follow without too many rabbit holes. I want to make sure I complete that lap and then come back later for details. You read so slow, I'm going to have to read the rest of this. It might be worth me hearing this part. A little razzle dazzle on there. Otherwise, it'd be painful.
Stop 4. Slow brain gets to think. The provider gateway. When the referee says use S2, the orchestrator calls system2 agent.decide_and_ act, which calls decide underscore S2. Decide underscore S2 is a switchboard. It doesn't think. It picks who will think. The same socket and plug pattern you saw with the referee. 2 plugs are available. Small agents, the in-process Python framework, default. Claude Agent SDK, calls out to Anthropic. Which one runs is decided by an environment variable, decision underscore provider. Set it to Claude underscore agent underscore SDK, and SlowBrain becomes Claude. Leave it default, and SlowBrain is small agents running locally. Big picture. The whole creature is built so you can swap its brain. Today, small agents. Tomorrow, Claude. Next year, something local. The loop, the referee, the memory, the goals. None of that changes when you swap brains. That's the whole point of the design. The chosen provider runs the S2 prompt the orchestrator built earlier, with goals, lessons, reflections, boundaries, and returns a string. That string is the creature's decision and action for this heartbeat. Stop 5. Boundary check on the answer. SlowBrain comes back with text. Before anything else happens, the orchestrator runs the same Hexas safety check it ran on FastBrain. Heartbeat underscore agent dot py colon 1153. If the answer would violate boundaries, it gets thrown out. Big picture. Same gate, both directions. The creature can't slip something past its own ethics by routing it through the smarter brain. Stop 6. Record what happened. This is the part that turns a loop into learning. 3 things happen. Heartbeat underscore agent dot py colon 1170 to 1203. MIDCA phase recording. Every step of this heartbeat. Perceive, interpret, eval, intend, plan, act gets stamped into a registry. By the end of the cycle, there's a complete trace. Here's what I observed, here's what the referee said, here's what I planned, here's what I did. Finalize underscore cycle. This fires a callback called Cycle Memory Bridge that ships the trace into long-term memory, Neo4j, via the Graffiti Service Gateway. Run underscore post underscore cycle underscore background spawns 3 follow-up tasks asynchronously. An episode optimizer, spec 043's What Did We Learn From This? A reflection pass, Did Anything Surprise Me? And a safety watchdog. Big picture. This is where one heartbeat stops being just a moment and starts being a memory. Every tick adds to a graph that future ticks can read from. That's the part that makes the creature an agent and not a chatbot. Stop 7. Back to sleep, then wake up again. Run, decide, returns. The heartbeat is done. The system idles, then a new heartbeat fires, every few seconds, controlled by a scheduler, and the whole thing happens again. The next heartbeat now has the previous one in its memory. That's how it accumulates. Your full lap in one breath. A heartbeat fires. The creature checks it has consent and knows its boundaries. FastBrain takes a quick look. A referee with a tiny dashboard decides whether that's good enough. If yes, it acts on FastBrain. If no, it gathers past lessons and reflections, picks a slow brain provider through a switchboard, runs deep planning, double-checks the answer against ethics, records the whole trace into long-term memory, kicks off background learning tasks, and goes to sleep until the next heartbeat. That's the lap. What this lap reveals. 2 design ideas show up everywhere. Sockets, not hard coding. Referee, slow brain, memory, goal evaluator. All of them are sockets. Real implementations plug in. This is why the codebase feels framey in places. It's deliberate. The loop watches itself. Every cycle gets recorded, scored for surprise, and that surprise feeds the next cycle. Without that, no learning. With it, the creature drifts toward strategies that have worked. You've now done one full lap. Good places to dive next when you're ready. The switchboard internals. Factory.py plus the providers it routes to. If you want to understand the Small Agents -VS Claude fork, the memory pipeline, docs/memory-pipeline.md. If you want to understand how a heartbeat becomes a graph node, the MIDCA phase registry. If you want to understand what those perceive/interpret/eval phase stamps actually buy you. Hint, it's how Spec 043 reconstructs episodes. Tell me what you want to ask now that the lap feels complete, or pick one of those three for the next pass.
All right, so I'll stop this here.